What led to the abnormality in Betelgeuse dimming? Updates in recent years, Betelgeuse has served as a center of interest and investigation for the scientific community. Around the end of 2019, the red supergiant Betelgeuse, which is 642 light-years away, mysteriously began to decrease, losing up to 60% of its normal brightness. Scientists believe that a supernova explosion is imminent because of something incredibly exceptional for a star that is one of the 10 brightest stars that can be seen from Earth. The earliest explanations and ideas discussed some sort of significant emission from the star that generated a lot of dust and obstructed the star's light, resulting in the odd dimming effect. We still don't know why this occurred or why the star had such an amazing emission, even if this is exactly what happened in this case. One of the most intriguing mysteries of the preceding few decades, the real impact was pretty dramatic. The star on the right is what it appeared to be at its darkest. Could the star's emission have been triggered by a black hole that was passing by? Or an ingested planet? Let's discuss these topics and more. By the end of 2019, Betelgeuse has diminished by almost 60%. Although the exact reason of the star's emission is unknown, a recent analysis suggests that a traveling companion may have played some sort of part. Betelgeuse's surface may have become darker because the intrusive object may have generated a tidal bulge by swinging close to the large star. Even though this explanation cannot fully explain the observed dimming, researchers recently published a report suggesting that it may have had additional effects on the star that made the situation worse. One of the stars in the night sky that is easiest to recognize is called Betelgeuse. It is often the 10th brightest star in the sky and can be viewed as Orion's fiery crimson shoulder. The red supergiant would spread from the Sun to the asteroid belt between Mars and Jupiter in our solar system, swallowing all of the inner rocky planets. Betelgeuse is on the verge of passing away. It is huge because its core has long since switched from fusing hydrogen to helium. The center is encircled by a hydrogen shell that is burning. The outer layers of the atmosphere are pushed outward by the energy from the fusion activities in and around the core, which causes the star to expand. When a star's red giant phase is over, it will explode as a Type II supernova. A Type II supernova happens when a star's core is no longer able to produce enough energy to sustain its enormous mass, which collapses under the force of its own gravity until the star is unable to withstand the intense pressure and explodes, releasing a massive amount of energy. Near the end of 2019, the star began to wane mysteriously, and astronomers surmised that the end was nigh. Up until the beginning of 2020, Betelgeuse's brightness decreased steadily, but in February of that year, when its brightness was only 60% of normal, the fading stopped and the star slowly began to recover. Its brightness is back to normal levels today. These images of the surface of the red supergiant star Betelgeuse were taken with the SPHERE instrument on the Very Large Telescope of the European Southern Observatory in late 2019 and early 2020. The image on the far left was acquired in January 2019 and shows the star at its usual brightness. The following images, however, were captured in December 2019, January 2020, and March 2020, when the star's brightness had drastically decreased, especially in its southern quadrant. The brightness returned to normal in April 2020. Betelgeuse records go back 50 years, and astronomers could find no precedent for the 2019 event. Therefore, whatever brought about the Great Dimming, as it came to be known, had to be extraordinary. Anything that caused the dimming has to have come from outside the star and not from a fundamental change in Betelgeuse's internal processes. This is because changes to the fusion processes take longer than a few months to take place. For such rapid oscillations to be sustained, the core simply has too much mass and produces simply too much energy during fusion operations. Astronomers have put up a variety of possibilities, such as stellar explosions and massive clumps of material in orbit. One reason for the brightness shift is that the outer atmosphere of Betelgeuse changed in shape. The distance between the topmost layer and the nuclear core and any surrounding shells at the center of a star determines its brightness. This is because stars are actually huge balls of gas rather than being solid objects. The stars are held together by their own gravity, but the, literally, explosive energy released at their centers balances out that weight. As a result, these two pressures constantly balance each other out on a star's surface. The star's temperature, which governs its brightness, is influenced by the equilibrium point's location. Astronomers can see what happens when stars rotate too quickly. The spinning force that results from this causes their equator to protrude relative to their poles. The equator of the star shifts away from the core as a result, which lowers temperatures and reduces brightness. Some stars appear brighter towards their poles than in their centers due to this gravity darkening. Although Betelgeuse's spin isn't fast enough for this to be a problem, bulges on a star's side could be caused by other things. A fortuitous visitor, like a tiny black hole, may swing too close to the star and cause tides to form on the surface, much like the moon does on Earth. The equator would darken, as would the star as a whole, with the tidal bulge in place. Betelgeuse was able to restore to normal when the visitor left, with all of its atmosphere in the right places, and start producing its customary large amounts of radiation. A team of astronomers investigated this possibility, and their findings were released in the monthly notices of the Royal Astronomical Society publication. The researchers came to the conclusion that the entire 60% dimming couldn't be accounted for by the mass and velocity of an unidentified, concealed visitor swinging into the Betelgeuse system swiftly. The passage of the visitor, nevertheless, might have had additional effects, including a strong starburst. The great dimming may have occurred due to a large amount of ejected debris and gravity darkening brought on by tidal cycles, temporarily obstructing our view of Betelgeuse. Another conceivable explanation for the star's emission is that a planet may have been sucked up by it. Throughout the past many thousand years, Betelgeuse has changed. Betelgeuse may have just recently entered this stage, and it implies that it will stay there for a very long time. It appears to have altered its hue in comparison to some of the earlier images from Chinese observers. In other words, it won't go supernova for thousands of years if these measurements are accurate. Another very important conclusion may be drawn from all of this if it has only recently reached this extremely active and reasonably large stage, and it has something to do with what you might have seen close to Betelgeuse. It's possible that early on, some planets here originated naturally. It is obvious that it never had planets, and there is probably no easy way to discover out right now. However, if it did have planets in the past few hundred years, it most likely ended up eating some of them as it developed. In a fascinating new paper, this was explained in great detail. They discovered that if the planet is exceedingly big and massive, the star itself would start to have unanticipated impacts on the surface and might even operate in incredibly chaotic ways. This effectively described what happens to some stars' large stars when they swallow certain planets. This in particular could alter the star's chemical composition and disturb its rotation. It has the capacity to produce a significant amount of unbinding energy, which results in the huge atmospheric release. It's likely that a massive planet recently absorbed by Betelgeuse, and that planet is responsible for some of the disturbance we're seeing as a result of the piece coming loose. Some of the star's parts were essentially flung off and fled into deep space as a result of the planet being devoured and now churning the star from the inside. The planet would need to be incredibly large, effectively a brown dwarf, to have the most dramatic effects. A terrestrial planet would most definitely be insufficient to explain these occurrences, but if Betelgeuse was orbited by a Jupiter-like object or perhaps something more massive than Jupiter, such as a high Jupiter, this might help. It's possible that astronomers will never fully understand what happened in late 2019. After all, there is just one instance of such in the archives of the magnificent star. A solution might come from more observations of Betelgeuse and similar red supergiants. We can only create the best story we can using the information we have, even though the combination of gravity darkening from a tidal bulge brought on by a close encounter with a black hole and the ensuing eruption of shrouding material may appear improbable. What do you think of Betelgeuse's enigmatic dimming? Share the video with your friends and let us know what you think in the comments section down below.